Okay, hello everyone. So it's your one of the mentors, Ryan, for SP3275 Science for a Sustainable Earth. This video is going to serve as a video tutorial on how you will go about using different methods, such as Excel or Python. I don't know how to use other methods, but these two are methods that I have tried and I know how to use. So I hope that this video will be useful to you in the second part of the topic water and oceans. So if we look at what we are covering in this video, it will be to be relevant on the second handout, water treatment methods, because in that topic, we will be discussing about how you can do certain tests to test for the concentration of certain pollutants in water or something like that. And you will also be doing an experiment where you will be required to create a calibration curve for the electrocoagulation of whatever solution that you will be given. And you will find out more by reading the instructions. So this video is just here to teach you how to use programs that are available to you to obtain a calibration curve based on data that you either, not that you already have. In this handout, of course, we will give you the data so that you can try to create your own calibration curve. But during the experiment, you'll be collecting your own data to create your own calibration curve. So from there, with these various programs, you will be able to calculate certain unknowns, such as to find out on concentration of an unknown sample, and also to calculate the limits of detection and limits of quantification, LD and LQ. So I will not go into the details of what LD and LQ are, because that is what we will be covering in the lessons. So this video will just be a tutorial on how you can use Excel, specifically two methods, LINEST and data analysis add-in, as well as how to use Python. Specifically, the package that I used was SciPy. If you know of other methods, please feel free to use them or to let me know, and maybe I can include them in future videos or whatever, future content. But yes, so let's go into the topic. I think in YouTube there is a way to create chapters. I will see whether I can do that. If not, you will just, I will put the timestamp inside and you just go to the chapter that interests you, or you can learn how to do both methods, because knowing what is available to you is always useful. Okay, so let's start off with Excel. Where's my Excel? Okay, so in the handout, you are given this, these values. I mean, you can type it up manually. There are not a lot of values, so please go ahead and type it up manually. Okay, so the first method I want to teach, okay, I mean, based on the order in that slide is LINEST first, right? So LINEST is a method that is actually just a function in Excel. And one issue with that is that LINEST just gives you a table of values from the cells, and it doesn't show you what they mean. So I show you what they mean here. Of course, if you forget there's something called Google, just go ahead and Google what it means, you know. Okay, you know what? I'm just going to show you how to Google, just in case you don't know how to Google. See, so if you go to Google and you type LINEST table and you go and search, there are so many things that tell you what they are. So you say how to use, and then you just zoom in onto this picture here and it tells you what it is. Okay, so let's move on. Okay, looking back at Excel, so how you do LINEST is you go to a cell and you type equals, and you just type LINEST, bracket, select the Y values, select the X values, and then, well, usually I choose true, and then you get all of these values. So all of these values will correspond to stuff that you might need. Okay, well, so there are some values here. So things that are relevant to you might be the slope, the intercept, the R-square value, the standard error, right? And well, maybe sometimes the standard error of the slope and the standard error of the intercept. Yes, so this is the LINEST way to do it. It's very simple. Another way is to use the data analysis toolkit, right? Because the data analysis toolkit is not only for linear regression, right? It's not only for linear regression, but it's also for, you can do a lot of things with it. So the thing is, you might not have the data analysis add-in already inside your toolbar up here, like what I have over here. So what you need to do is to go to Files, click Options, Options, where's Options? Options down here, Options. And in Options, you click Add-ins. Under Add-ins, you go Manage Excel Add-ins, and you click Go. And you see this Analysis Tool Pack, and you select, you click the check mark, and you click OK. Okay. And then you should see appear in your Data tab over here, Data tab. So the Data tab would have Data Analysis. So you click the Data Analysis, and you wait for something to happen. Okay. And the one you want to look for, okay, as you can see in the Data Analysis add-in, you have a lot of various things that you can do. But the one that you can find out what you need in the future, right? You can explore. But the thing that we really need for our analysis here is regression. So input the Y range. This is Excel, so we can just select, right? And then input the X range. Okay, and well, you can input it inside a new worksheet or whatever, up to you. And you just click OK. And then you get all of the values here, right? So don't manually do this, you know, just ask it to do it for you and you auto fit. So over here, you can see a lot of other values that LINEST doesn't tell you. LINEST is usually sufficient if you just need to know those values that I highlighted earlier. The regression add-in from the data analysis add-in tells you a lot more information, such as like the p-value of your intercept. This is particularly interesting because it tells you whether it's whether the intercept is like 0 or not, which might be important in certain cases, right? Where say your intercept is supposed to be 0. You can find out more about this. Not going to tell you too much. What would be interested in what we are interested in is the R-square value, the standard error of the regression analysis, as well as our coefficients, so the intercept value and the slope. Right. Okay, so that's the end of the Excel method. Now let's move on to Python. So I use Visual Studio Code. It works exactly the same way as Colab, Jupyter. I just use this because I've been using it from the start. So there's no particular reason why I choose VSCode. Okay, so as usual, the first step that we do is to import the packages. Over here, we will be using NumPy and SciPy. NumPy is because of the arrays that we'll be using, and SciPy is to do the statistical analysis in the linear regression. And I think SciPy uses NumPy arrays, so we need the NumPy. Okay, and obviously Matplotlib to do the plotting. Okay, so first things first, we create the raw data. Okay, I did the hard coding here because there are not a lot of values, but of course, if you have a large data set, please go ahead and use the pandas, whatever pd.read/cfv, whatever. I don't remember such things, but yeah, go ahead and just do whatever you want. Okay, so create the raw data. Okay, I need to run this. I need to run this. Okay. Next, okay, I put create a model with NumPy arrays, but that's really because I didn't know what the title should be. But yes, we need to create the NumPy arrays for SciPy to work. So I know this looks a bit inefficient. You can combine the two steps together. There's no problem. I'm just putting it here so it looks a bit clearer because I define what my X and what my Y is and put it into the array. Then we obtain our regression data. So I think we're all familiar with the linear model of y equals to mx plus c, where m equals to the gradient. Right, okay, let's just write it more clearly so that some people are not so lost. So it's the gradient multiplied by x plus the intercept. Okay, so what we want to do is I put regression equals to stats.linRegress xy. So what this does is that it gives you like a list of values, a lot of values actually. It tells you the slope, it tells you the intercept, it tells you the p-value, it tells you the standard error. But take note that the standard error that they give inside stats.linRegress is actually the standard error of the slope. Something I learned today as well when I was trying to figure out how to do Python. Okay, I am not a Python expert, but I figured this out. So you can too. Okay, so how linRegress does it? Okay, to see this clearer, actually what we can do is, oh no, not this one. So what we can do actually is we can see how linRegress looks like. So, right, so actually what it gives you is like this list of values, not list, I don't know what you call this, but yeah, a tuple, yeah, okay, it gives you these values anyway. So it records the gradient as the slope, the intercept as the intercept, the R value. So they don't give you the R squared, they give you the R value. And then they give you P value and standard error and the standard error of the intercept, right? So it's easier for me to extract the values like this. So I call the gradient and regression.slope, intercept as regression.intercept. And because we're interested in the R square value, so we need to take the R value and then we square it, okay? So after getting these values, okay, of course, I'm not saying that the other values are not useful. It's just that they're not relevant in this video tutorial. Okay, so I'm just going to use the gradient, the intercept, and the R square value for this. Next, we want to plot our values with the scatter plot and the linear fit, right? So I create another list of x fit with between the range of 0 and 1. Why is 0 and 1? Because our original data set is from 0 to 1. So it is important that we don't extrapolate. I'm not saying that you cannot create a linear fit with like a larger range. There's nothing wrong with that. It's just that for the purpose of this, it was easier for me to create a list that was like that. You can use as many values as you want. I put 100 so that it's like I can definitely get a nice line. Anyway, this is a fit, so it'll definitely be a nice line. Y fit is definitely an empty list. The way I did it was to create a for loop, and then I just plugged in the values to create the Y values. And from there, you get your fitted line. Okay, so I'm sure we all know how to plot stuff already, but I'll just go through it anyway. So we plot the scatter of the concentration as the X value and the absorbance as the Y value. So just remember it's X and Y. And I put the marker as dots so that, well, I mean, it's a scatter plot, so it can be dots. You can put other things as well, but I choose dots. I put the color as black. You can choose any other color you want. Now, the reason why I put concentration and absorbance here is so that it's a bit clearer what it is. Of course, I could put X and Y. There's nothing wrong. Okay, so next we plot the fitted curve. I'm trying to put both of them together, so I can put them on the same curve, on the same plot. You get it? Okay, so plt.plot X fit, Y fit, and then I'm trying to make this a dotted, a dash line. So I use the dash. You can use one dash also. I think there's nothing wrong. Color equals to M. I think that is magenta. And then you just do your customization. You know, plt.title, linear fit calibration curve, plt.ylabel. Blah blah blah. Okay, so if you wanted to add in the equation of the graph, you just put plt.text, and then you play around with the values. I don't know what it should be, but let's just say 0.5, 0.5. It's always good to start with 0.5, 0.5, and then, okay, you know, I'm not going to put it, but I'm just going to take an example like this, right? So it's going to be there, which if you're okay with it, then we just leave it. If not, just change the values to wherever you want to put it. Okay, so it's going to look something like that. If you wanted to add another line, just add another line, you know, you want to put 0.5. Okay, so now it's going to be at the same place, but lower, so 0.4. And then we put the R square value, maybe R square equals to something, okay, yeah. And then, yeah, so we'll be there, and yeah, okay, do the necessary changes, you know. And it's Python, play with whatever you want. If you wanted to make it like, If you wanted to make it like more mathematical, you could put the dollar signs. And then yeah, see, it'll become r squared. Okay, so next, inside the worksheet, you are asked to solve for the unknown concentration. So the unknown concentration is 0.512. I'm not going to show you the answer because it's up to you to figure it out. But let's do the math, right? So y equals to mx plus c. If I wanted to find x, what do I do? Right? So x equals to what? Y minus c divided by m, right? Y minus c divided by m, which is exactly that, right? So the unknown is the y value, the unknown value 0.512 minus the intercept divided by the gradient. You should know how to do this. Okay, next. Inside the notes, we told you how to calculate LD and LQ. So here's the thing that is a bit okay, I might sound biased about this, but in Python, you have to find out the standard error of the regression yourself. Okay, so I didn't know this, but I had to figure this. I had to go in Google for the formula, and this is the formula I found. If you want to read up more, I can put the link in the description. You can figure out why. But okay, so to get the standard error of the regression, we need to get something called the adjusted R square, which follows this formula, and multiply by standard deviation of y. So here's the thing: if you use the NumPy way of calculating the standard deviation, it gives you the population standard deviation. But because this is not a population but a sample, we need to so the difference in the formula is that in the square root, if I'm not wrong, for the sample it's 1 over n minus 1, and for the population it's 1 over n. So that makes a bit of a difference, right? So the way to counter this is you add this thing called DDOF equals to 1. So this tells you if you're not wrong, is the n minus something. So if you put 2, it will be n minus 2. Okay, so in our case, we are interested in n minus 1 for the sample. So DDOF equals to 1. Okay, so just plug in the formula and then do this, and you should get your value of the standard error. And then after that, use the formula that we give you for LD and LQ to calculate the relevant values. I'm not going to show you the answers here because you're supposed to find out yourself. Okay, so with that, I think that will be the end of this video. Right, that will be the end of this video. If you have any questions, please feel free to message me, email me, or find me anytime. Okay, and see you in class. Bye.